it's Cinnabon. Please move it, Cinnabon. Okay. Hey guys, and welcome back to Study Journey. It's Mary, and I'm back with another Problem of the Week AMC 10A problem. And this is going to be about sets and probability. So without further ado, let's get on with the video. This is AMC 10A Problem 18 from the year 2010. Bernardo randomly picks 3 distinct numbers from the set 1, 2, 3, 4, 5, 6, 7, 8, 9. So the keywords here are 3 distinct numbers, and then from this set. And then he arranges them in descending order to form a 3-digit number. Sylvia randomly picks 3 distinct numbers, like Bernardo, but it's from the set 1, 2, 3, 4, 5, 6, 7, 8, which we can tell here that Bernardo's set just has a number 9 and Sylvia's doesn't. And also arranges them in descending order to form a 3-digit number. So basically the same, except for the fact that their sets are different. So it is asking you, what is the probability that Bernardo's number is larger than Sylvia's number? So you're trying to find Bernardo's number is larger than Sylvia's. So we can solve this by breaking this problem into 2 cases and then adding up the possibilities of these 2 cases. So our first case, case 1, would be when Bernardo picks a 9. If Bernardo picks a 9, then his number is guaranteed to be larger than Sylvia's because Sylvia doesn't have the number 9. And then case 2 would be when Bernardo does not pick a 9. So remember, probability is the ratio of the number of ways a specific outcome can happen, and then the denominator is the total number of ways that all possible outcomes can happen. So here we know that the total number of outcomes is 9, choose 3, because in his set he has 9 numbers, 1 through 9, and then he arranges them in descending order to form a 3-digit number. So we are choosing 3 numbers from this set of 9 numbers. So this was the total number of outcomes, which will be the denominator. So what's the numerator? The numerator would be when he chooses 9. So we know that one of the 3 numbers that he chooses has to be 9. So 1 is the 9, and then times how many total number of outcomes are there when he picks 2 numbers of the remaining 8? Well, that would be 8 numbers, choose 2. Because you already chose 1, which is the 9. So there are 8 numbers left, and then you choose 2 out of the 9 to get your number of specific outcomes. We know that we are trying to find the combination of these 2 sets. So we know that combination formula is n choose r, where n is a total number and r is the number of choosing objects from the set. And then it is n factorial over r factorial times n minus r factorial. So when we substitute this into this equation, we get 8 factorial over 2 factorial times 8 minus 2 factorial. And then same for the bottom. This would be 9 factorial over 3 factorial times 9 minus 3 factorial. And then we can simplify this. And then we get here, and then we can simplify this, and 8 times 7 divided by 2 would be 4 times 7, which is 28, and then the bottom would be 84. And then this simplifies down to 1/3. Now, let's go to case 2, which is when Bernardo does not pick 9. Okay, so let's talk about this. If Bernardo doesn't pick a 9, then that means he's picking a number from 1 through 8. And since Sylvia is also picking a number from 1 through 8, then they are picking from the same set of numbers. So the probability that Bernardo's number is larger is actually equal to the probability of Sylvia's number is larger, because they are in the same set and they're picking the same amount of numbers. Since we're ignoring the 9, the probability that they will pick the same number is the number of ways to pick Bernardo's 3 numbers divided by the number of ways to pick any 3 numbers. So what do I mean by that? So first, the probability that they will pick the same number. So the probability of Bernardo and Sylvia picking the same number, this would be 1, which is there's 1 outcome over the total number of outcomes, which is 1 over 8, choose 3. which is 8 is a total number, and then you choose 3 out of those total numbers. So if we simplify, we get 1 over 8 factorial over 3 factorial times 5 factorial. And then we can simplify that, and then we would get 1 over 8 times 7 times 6 over 3 times 2 times 1. 3 times 2 is equal to 6, so we can cancel these two out. And then we would just get 1 over 56. So the probability that they pick the same number is 1 over 56. Okay, so now let's find the probability of Bernardo picking the bigger number, which, remember, is the same as Sylvia picking the bigger number. So this is when they don't pick the same number, which will be 1 minus 1 over 56. And then over 2, because we had to divide it by 2, because 1 minus 1 over 56 is the probability that they don't pick the same number, and then when you divide it by 2, it is the probability that he picks the bigger number. And then we can simplify this to 55 over 112. Now remember, this is when he didn't pick a 9. So we know that when he did pick a 9, the probability that he picks a 9 is 1/3. So the probability that Bernardo does not pick a number 9 is equal to 2/3. We got this from 1 minus 1/3. Now we have to use this probability to factor out the fact that he didn't pick a 9. So we put these two equations together. So we do 55 over 112 times 2/3. Because remember, 2/3 is when he doesn't pick a 9, and 55 over 112 is when he picks the bigger number, when he doesn't pick a 9. So this probability would equal 55 over 168. And this would be the answer to the second part. Now we just have to add the two probabilities together. So we do 1/3 plus 55 over 168. And then if we solve this out and then simplify it, we get 37 over 56. Now let's take a look at the answer. We see that the answer is B, 37 over 56.